Arty Friday session. We are very happy to have you with us to another talk. Just once again, today we are very glad to welcome Karol Rogowski. He's head of engineering at SoftwareHut and a teacher at Białystok Technical University and co-founder of Meet.js. Białystok is also an author and a big fan of technology. Karol has more than 30 years experience in IT and know how to make architecture work for business goals. Today, for his session, is called Tailor-made architecture. Karol will explain how to design architecture that fit business needs. And he will also show us how to find and choose the most important business driver, how to use impact mapping to link them to results, and also how architecture driver can help create a strong solution. He will also show us the C4 model that can help to draw and explain architecture in a simple way, and how to use risk assessment to keep a good balance between a new idea and stability. But I will let him explain more. I can say it's a session. But before that, I will be a simple and practical journey into making flexible and strong architecture. So I will let Seme for the next step of our session.
Good. Thank you very much. Thank you very much, Rodrigue, for this presentation. So good morning, good afternoon, everyone, and welcome to this usual 1-hour Friday session. It's part of the Arty Friday series that we have every Friday, same time. Archie Fridays, as Rodrigue already mentioned, is dedicated to advancing enterprise architecture and data management. So this is a dedicated platform that unites professionals, architects, and also tech enthusiasts to share their best practices in enterprise architecture, data management, and also digital transformation. So I'm Semi Ben Salem, data architect, and today we will dive into a critical challenge in enterprise architecture, which is tailor-made architecture in dynamic business environment. And we have a special guest for this session, Karol Rogowski. So thank you very much, Karol, for joining us, and thank you for your valuable contribution, especially for the tight schedule to plan and to present this session. And this is always a pleasure to have you with us. So without taking so much time from the session, I will leave the mic to Karol to present the topic of today. And thank you very much again for joining, and enjoy the session. Thank you.
Okay, so if I understand correctly, the mic is mine. Yeah?
Yeah, sure.
Yes.
Yeah, okay. First of all, thank you very much for inviting me. It is always pleasure to talk to other tech enthusiasts. And yeah, as it was introduced, I'm a head of engineering at the SoftwareHut company, and today I'm going to tell about tailor-made architecture and basically what are the key concepts that can bring value to your project or bring to a downfall. Okay, so yeah, this is basically the same slide. I'm Karol Rogowski. I'm work as a head of engineering at the SoftwareHut. We are the software company based in Poland. As an extra job, I run a private consulting company that focuses on the IT. So if anybody would like to reach me, here is my email. My LinkedIn can be found based on my name. And yeah, before we dig down to the technical stuff, I would like to ask everyone a question, and you don't have to type. You can answer in your own head. What do you think was the phrase I googled to receive this image? I will give you like 10 seconds. Okay. Okay, to receive this image, I have
Yeah.
Googled beautiful architecture, and this is what we received. Okay, it is a it is a chance that it is a containerized, but it's well organized, it does its job, it fits well into the environment, it's great. Okay. Now the harder part of the question: what I googled to receive this image. As with the previous question, I will wait around 10 seconds for you to try to guess it. Okay, to receive this beautiful image, I have googled beautiful Soviet architecture. Okay, and this is what pops up, and it shows how the architecture of an IT project that wasn't well planned is organized. There are like 3 huge modules that look awful, and they are connected with a single pipeline. Okay, and I'm more than sure that each one of us was the project that was organized in this manner. Okay, so few monoliths that were created with no thought, and they're simply there and are being connected by something. In this case, it's a bridge, or I don't know. In our case, it's probably HTTP request of some sort. Okay, so yeah. And during this presentation, we will talk about how to end up here and not here. Okay, this is going to be the main goal. So yeah, first of all, when we are designing any solution, any business solution, when we are thinking about any kind of software architecture, there are drivers. We may be aware of that or not, but basically each task we are given boils down to 2 things: benefits we can gain or problem we can solve. Try to think about it for a second. You either creating something new to gain some benefits, or solving some kind of problem that was caused by you or by the ever-changing landscape of the IT world. Okay, but basically everything that we are doing can be put in one of these 2 buckets. And yeah, when we are looking at the goal that the thing what we are designing is to match, basically there is a cheat sheet that can tell us what the goal will be. So what do you want to achieve with this? When you are presented with a new task, try to answer these questions. Okay, for example, what goal will we fulfill? Okay, so if there are clearly defined goals, that will mean that the task was done. Who will save time? Because more often than not, when we are when we are developing something, we are either saving time for the cloud, for the calculating machine, so we can pay less, or saving time for a customer to be able to browse our products in more convenient manner, to do checkout faster, whatever. What benefits will the client gain? Okay, this is another super important topic. So what will be the clear benefits that our client will gain over the clients of our competition? This is also very often the task we are given. What problems are we trying to solve? Okay, another example. And what opportunity will it give? So for example, introducing AI to our process will give us opportunity to give the AI the tedious task, and we won't be forced to do them. Okay, and yeah, that was the easy part. The harder part are the criteria, and we, as an architects, should be very aware of this part, because junior mid developers may not be aware that the job we are doing is measurable criteria. So first of all, if we are given the task of benchmarking and improving the performance of an application, we always have to be aware that it will be measured. So we have to know how will it be measured. Are we going to measure the consumption of an Azure or AWS resources? Or will it be or will it be the time that the consultant needs to fix a report or something? Okay, how will we confirm that it brought value? Okay, so for example, if we are, as I mentioned, improving the time that customer can find products in our shop, how will we say if this brought value or not? Okay, it needs to be measured. So for example, we know that if we improve the time, the fact that it brought value of it, or will be confirmed by a KPI we will receive in like 3 months. Okay, but there is an information. We need to wait 3 months to know if our task brought value. Who will ensure that the goal has been met? Okay, and again, this is the job for the product owner. It needs to be confirmed by us that we are waiting, for his or her confirmation that the goal was met. Okay, again, if we are giving any kind of architecture task, we need to have those criteria in place to know that our job is done or that we failed. Okay, either way, any information is better than no information. And yeah, if we are talking about the task we are given as an architect, I would strongly recommend getting yourself familiar with the concept called impact mapping. Impact mapping is a way of depicting how the thing we are developing, will, yeah.
Yes, sorry, I have a question about the previous topic, the goal. The question is how to ensure that the goals are smart, I mean specific, measurable, achievable, relevant, time-bound, and they ask if there is any framework for that.
Um, Okay, very good question. In our company, usually this kind of job is being done by the project managers, and this is their responsibility to do it. Yet, yeah, I'm not an expert on defining the task boundaries. I can give my insight, and the good framework to see how the goals are being defined and what are the boundaries is the mentioned impact mapping. Because,
Okay.
for example, if you see that you have a huge goal for grow mobile advertising, okay, and you go down in the line, you see actors, you see which elements will be impact, and at the very end, at the very right end, there are deliverables, and this is the thing. If you those are the elements, if defined correctly, will tell you what tasks needs to be delivered for the growth of mobile advertising to happen. And based on that, you create a story. For us, the rule of thumb is that if any story takes more than 2 work days for a developer or designer or something like that, it needs to be cut into smaller chunks so that the smallest amount of stories the developer is being able to deliver during the week's work is 2. Okay, we try not to go below that number. So 2 huge stories plus some kind of testing, meeting stabilization is the rule we force upon ourselves in our company. But it depends on the lifestyle of the application, and you can't say that something is too big. Maybe for you, if you are working on the banking industry that needs to shut down the entire web page for an update, delivering once every 3 months is perfectly okay. And in that case, for you, the reasonable size of a goal will be to develop it for 3 weeks, and
Okay.
that's perfectly okay. So as long as the development time doesn't impact your business and the value you are bringing, you're not slowing down the QA process, the UIT environments, that's okay. It is highly dependable on the product you are on. So no clear answer, sorry.
Okay, great. Thank you.
Okay, another hand raised, or did I?
No, it's the only one. I take the second
Okay.
one is almost the
Okay,
same.
cool. Okay, cool. Yeah, thanks.
Yes,
But great, good. Yeah.
sorry, we have another question. It is just dropped into the conversation. So I don't know if the question will be covered by so in the upcoming slides. But so please, Carol, if you are going to cover this question in the upcoming slides, so you can just
Yeah, sure.
stop me. But the question is, uh, how can we really, or how can the impact mapping you are presenting here in this slide, how it can be effectively be integrated into the architectural design process that we would define for the project or for the technical solution, in order to ensure that it is aligned with those principles and with those objectives that we define with the stakeholders.
Uh, yeah, I will be elaborating on that in the next slides.
Good.
So if the person asking the question will feel that the answer was not sufficient, please retype the question. Okay.
Okay,
But
good. Thank
okay,
you.
cool, cool. Okay, so yeah, impact mapping show us the impact the current task or the current plan of an application will have on our application on different levels. And yeah, hold to that thought. Yeah, this is a marketing slide, so to boost the morale, because we are going into more details right now. Basically, each one of us wants to do less and earn more. Yeah, we learn to earn more and do less. Okay, keep that in mind. Yeah. When we have the when okay, I will hide your hand. Okay. Okay, when we have the requirements, hopefully done by an impact mapping, we need to get ourselves familiarized with architectural drivers. What those are all kinds of external and internal elements, vectors that influence our job, because very few of us are lucky enough to work on the greenfield project when we are the only boss on ourselves. We develop what we want when we want. It
Sure.
rarely happens. It's only for our private GitHub repos. Okay, it's a fairy tale. It doesn't happen almost never. So basically, there are 6 main areas when it comes to aggregating architectural drivers. First one, and the most important, are functional requirements. Remember, first of all, you need to bring requirements to the customer, because otherwise he or she won't pay you money. Okay, that's that. Okay, and there's no way around it. They have to see that the thing that they required works. Okay, this is the first and the most important driver that overrides all the others. But there's always a but. There are also other drivers that we, as an architects, have to be aware of and have to be able to present them to the customer and discuss what kind of impact do they have on the development process, on entire application life cycle of keeping the application running. Okay, and there are quality attributes, there are stakeholders concerns, there are systems and interfaces, there are limitations, and there is context. Context is basically everything that we weren't able to put in any of the previous architectural driver buckets. Okay, because there is always a context. For example, you don't like someone in your team, you don't want to use some kind of API because you have used it and you know that it's crap. Okay, so there's a context of everything that we won't put in any of the previous buckets. Okay, we won't discuss functional requirements because it's super unique to each and every application. Okay, and yeah, it's impossible. But yeah, we will start with quality attributes. Okay, sorry, my mouse ran away. And basically, the book, the software architecture and software architecture, the hard parts, lists around 60 quality attributes when it comes to architecture. And basically, the 7 most important one is the performance. So how our application and our architecture performs, and scalability, so how well it scales, reliability, how reliable it is and how stable, availability, so how unlikely it is for application to be unavailable, security, reliability, so that's quite easy, maintainability, so how easy it is to extend our project, to build on it, to add new functionalities, to integrate new elements, and usability, so how easy it is for other users to use it. Okay, I see two hands, or no? Yeah, because I wasn't looking at that monitor. Okay, and those are the seven main quality attributes that our application will be judged based on. And the problem is that, especially in the AI age, when customers more often than not, before coming to us as a software house, Google, chat or ask the AI, what should be the best performance my architecture has to have? And the AI basically lists all of those parameters. Okay, so it has to be extra scalable, it has to be extra secure, extra perform, extra everything. And basically, this approach is madness, because this kind of approach, that it is super scalable, super fast, super performant, works for the companies that do have millions of dollars, millions of users, and then can afford such a processes, such a computing power. So it works for Amazon, for Google, for the really, really big players. And if we are creating an MVP application, we don't need to have a top-notch performance. For MVP application, the user journey doesn't have to be perfect. What needs to be perfect is the happy path, okay? Because we need to test the market. If our resources are limited, we can ease on, for example, availability. If the application is unavailable for an hour a year, it's okay for us. But if you want it to be unavailable only for a minute a year, those are totally different amounts of money we need to pay, both for the developers, the architectures, and for the cloud that will keep it alive. Okay, and we as an architects need to be aware of that, and we need to be able to discuss it with our clients and show them the trade-offs. Because if their budget, for example, boils down to, I don't know, 50,000 euro for a quarter, then they won't be able to match all these quality attributes, and they would want to. I guarantee it happens more and more often that we need to discuss and show them that, for example, if we want it to be super secure and super available, you will pay that much money for infrastructure. But if you're okay with it being down for an hour a year, you will pay like 100 times less. And this is the moment when it changes. You have a top-notch performance. For the application, the second driver are the stakeholders. Please keep in mind that you're not the only person involved in the application development process. Okay, maybe in development, but in lifecycle not. There are, I will finish the slide and go back to the question. First of all, there are user concerns. More often than not, the task we are being given was brought to light because someone filed a report or report a bug. So the main goal of this task, any task being developed, is to make users happy. Okay, there are business concerns, so we need to make business happy. And those kind of concerns, for example, can be that we need to develop it in 2 weeks because, I don't know, the Christmas is coming, or the Black Friday is just around the corner, or there are holidays in 2 months and we need to start creating supermarketing campaigns. Whatever business that pays us has in mind, we need to take it into consideration. And there is a third factor that very often gets overlooked, and it can lead to a disaster. there is a developer concern. And what I mean by that, please keep in mind that developers are people. They have their vacation schedule, okay? They have the stack they have been working on, and I know that new technologies sound sexy, but learning them takes time, and learning them on the production level takes even more time, okay? Because for example, I'm a .NET developer for like 15 years, something like that, and I'm sure that if I'm forced to, I will develop a Java application or Python application, but for me it would take much more time, and fixing the bugs will take super more time. Okay, that's why those factors needed to be taken into consideration: users, business, and developers. There are three stakeholders at minimum during your development process. There can be more. For example, if you are using an external company, when you have to work with their experts, but there are always at least three. There was a hand raised, sorry. There wasn't? Okay, so I'll continue. Okay, another driver are the systems and interfaces. Please keep in mind that our application doesn't work in the vacuum, okay? The the IT projects are as interconnected as they have never been. So during the architecture design and the overall project design of how our application will be delivered, we need to think about what integrations need to be placed, what third-party services we will introduce in our application. So, for example, some kind of monitoring or webhooks, whatever, external APIs, okay? How the deployment is going to look. Are we going to use GitHub Actions, Octopus, Jenkins, or whatever? What monitoring tools will be integrated into our application? Because some monitoring tools also require endpoints to be presented. Or are we going to use some kind of health check methodology? And this also forces us to create some kind of small but still infrastructure in our project to be able to deliver these health point endpoints and all the production management. So, for example, the business we are working on forces us to put a new version of our product into 2 weeks on the UIT for them to be able to internally check it, because this is a financial application of a high risk, and then they need this buffer to make sure that what they are presenting to the market is 100% safe. Okay, so also take these these factors into consideration when developing your architecture and your life cycle and your application life cycle. And there are always a limitation. First kind of limitation that we will see are the technological one. For example, we had a situation some time ago that there was a client that was working on the C#7, so the version that was released, I don't know, like 8-10 years ago, something like that. And one of the requirements was that they won't allow the version of the framework to be updated, nor the version of the language to be updated, because they are sure of this technology. They have been working with this version for years, and this is set in stone. If we are to work with them, we have to be developing in this particular version. And that's that. Okay. There are organizational limitations. For example, especially if you will be developing or designing a product for a large company, they will have their standards. So the way that you can log into application, the MFA that has to be placed, I don't know how data needs to be encrypted, what kind of backup policy needs to be in place, what third-party integrations can and cannot be placed in the products that they will introduce to their ecosystem. or what kind of, for example, monitoring tool has to be used, because they are using it all across the organization and they won't allow anything other to happen. So also before even trying to design an architecture, keep in mind that there are limitations: technology, organization, and external ones. The very good example of, for example, external limitations is when you are developing anything for the ABI rates. They have a right that data can't leave the servers that are geography placed in their country. The same thing is for the US. The financial and the medical data can't leave US, and that's set in stone. You cannot discuss with it. There are even some organizations that force you to use AWS or Azure because of some certificates they were able to present, and at that point you are mandated to use that kind of software, that kind of data storage, that kind of data annotation whatsoever. Okay, please keep that in mind, because it's no point wasting time designing an architecture that you will have to change because you have overlooked some kind of those limitations, and there will be no discussion. Nobody will care that you have spent a week developing something if it doesn't match, for example, the organizational requirements, and that's that. Okay, so keep that in mind before starting your work. Okay, so yeah, that was the sad part, because basically I was talking for 20 minutes about the things that limit us. And yeah, the good thing is that once we have all that in place, we know which limitations, which drivers we have to meet, we can start working. And our work is cool because at the very start we get to draw pictures, okay, draw diagrams. I'm an old man. Been working with the computers for almost 20 years. For 17 years, someone wants to pay me for that, and I start working by drawing diagrams on the piece of paper. Okay, and that's pretty cool. But diagrams you use on the digital version are cooler. But before we start drawing diagrams, creating diagrams, to be precise, we need to answer the question: who is going to create some kind of diagram, for whom this diagram is being created, and why? Because drawing is cool. For yourself, you can draw whatever you want. But if you are working on many levels, so you are working, because as an architect, very often you will be working both with the C-level people, with the business, with the developers, and with the external consultants. There is a great book about it. It's called the Architectural Elevator, and it focuses on the way you are working with people working on the different level of the building. Right? You're riding an elevator, stopping on the floors, and it presents different approach to different kind of people. I can highly recommend it. Okay, there is no link. I'm not supposed to buy that. It's a great book. So yeah, I can recommend it highly. And when you answer these 3 questions, we can start creating diagrams. And the best approach I can recommend right now is a C4 model. So the model of 4 levels of zooming in or zooming out, depends where you start. And there is a context, containers, components, and code. So 3 Cs. That's where the C4 comes from. Okay, and yeah, basically this is a Maslow C hierarchy. The context is a very foundation of our diagrams. Okay, is the highest level and needs to be created always. The containers, in my opinion, also have to be created always. As it comes from the components and code, not so much, but yeah, I will elaborate on that in just a second. Okay, as I said, C4 approach can be tackled from both ways, either zooming in or zooming out. I will go with zooming in. So we have contexts, and basically this is the as high depiction of your system as you can imagine. Okay, so at this example it has 4 elements. It has internal banking system, some kind of mainframe, some kind of external system that's being used to send emails, and an actor. Okay, in this approach there are also an actors to depict how the application works. And this is the kind of diagram that if I work in the project is being created always. It's easy to create, it's fast to create, it doesn't take a lot of work, and it helps during the talk with anybody on the I want to say on the building, so the book reference, basically with anybody. You can show it to the C-level people, you can show it to the business, you can show it to the internal and external consultants, you can show it to your developers, and it will bring much value because they will know at least where they are. Okay, so you can say them, okay, say to them, sorry, you are working on an email system that is over here. Cool. Okay, that's a great place to start. And who creates this diagram? Probably you as an architect. Okay, it will be the best person to do it. The second diagrams are the containers, and yeah, I try to create them always. Okay, maybe not always. If I get to talk to anybody other than the business and C-level people, so we are going to the nitty-gritty details, this diagram is being created. Okay, in this diagram, we are going a level deeper. Okay, so now we see that our banking system contains of web application, single page application, mobile app, API for the API for the application, and database. And again, if we are start to talking more seriously, we are past the element of discussing if you want to work together and actually getting to work, getting to estimate the project, or preparing to review it or pen test it or whatever we are doing with that. This diagram has to be created. And again, I believe you as an architect, we are as architects, sorry, are the people who need to create it, probably or maybe with the help of lead developers if there are such connected to the given projects. And again, it gives us view and helps us with during the talk with anybody. Okay, super useful. I highly recommend creating it. Components. I would love to lie to you that we are always creating this diagram, but we're not. These diagrams shows you the action and the actual components that are used in the application. And again, if we know that application will be prolonged, we know that it will take us more than a half a year, or it will include many developers, I encourage the developers to create it and to maintain it. And this is one more very important thing, because if you forget to maintain something over here or something over here, there are good chances that nothing will happen, because the chance that a new application will arise is not so big. Okay, if we had a web page and mobile application and we are changing something, adding new features, this diagram may stay. But this diagram has many pros. Okay, it shows in details what are you working on, what is the level of completion. Okay, because you can add numbers. So for example, you know that reset password controller passes 4 out of 5 unit tests. Okay, so now you know where you are. However, if you neglect the job of updating this diagram, the person with the new version and the person with the old version may be totally disconnected, because they will be looking at totally different elements and planning the work based on that. So this level brings a lot to the organization of work, especially with many developers. but you have to maintain it. Otherwise, you will be screwed, right? If someone doesn't update the version and adds, I don't know, reset passwords for MFA controller or whatever, okay? And yeah, try to do it if you have time, if you have more than 3-4 developers working on the same portion of code, but maintain it, okay? And the last one is a code, and basically only times when I actually create this level of diagrams is if the client requests it, because it's from some kind of official bidding or something like that, and I generate it automatically. I have never in my life created by hand. Okay, it's an honest answer. And yeah, but again, do this one always, this one almost always. Try to do it for larger teams, but keep it up to date. Okay, very, very, very important. Okay, and at the C level, at the C4 model page, there is a bingo. Basically, if your current diagram matches these boxes and you got a bingo, you should start using C4 model. So you can try it for yourself. Usually, you will get bingo very, very fast. Okay, as we are talking about diagrams and that kind of stuff, there is a word that's called, I hope I pronounced it correctly, Zamak, something like that. Yeah, it sounds like some kind of ancient god or DC or Marvel villain, more or less. And yeah, it stands for software architecture as a model, as a code, sorry, because nowadays everything can be as a code, okay? And it's super useful. I'm not talking about bicep or anything specific when it comes to deployment. It's not that talk about technology and CI/CD organization. Before that, the C4 modeling works perfectly well with a tool that's called Structureize. And it allows you to create C4 models up to C3 level. I haven't tried for the C4 level, but it probably works. And you can maintain it as a code. And as I said, for the components, I don't want to, for the components, if you want really to keep your C4 models up to date, and you should, try Structureize. It's a simple markup language. You simply put an elements in JSON-like format, and it generates images. It's easy to track. You can put it into GitHub, and you have all your you have all your software architecture diagrams in one place. So if you go with the C4, do it the right way. Use Structureize language to visualize it. Yeah. Okay, risk. Yeah, the risk I took was calculated, but man, I'm bad at math. When we are designing an architecture, we are talking with the client, with developers, with the external companies, with certification companies about the architecture, we need to be aware of the risk. Okay, and basically there are two types of risks, and the third one is a hybrid, so it doesn't count. Okay, there is qualitative risk, there is quantitative risk, and there is hybrid risk. Qualitative risk is not measurable in any mathematic way. So, for example, you know that your risk is the fact that your lead developer will be having a baby in 3-4 months, or he or she is having an operation, or he or she is ill health, or is looking for another job. Okay, this is the risk you cannot measure in simple numbers, because you know that if he or she is having a baby, he may be not feeling well, he might not get a lot of sleep, or baby might get sick, and the quality of that person's work may decline for a half a year. Okay, another risk is when you are working with external companies, for example, to deliver monitoring mechanism, because the thing with the external companies and external API is that it's super hard to get SLA from them. It's nearly impossible from they to say we are stable for 99.99% of the time. Okay, it's impossible to get, and you need to take that into account. That if they break, maybe not your application won't be dead, but you won't be collecting the telemetric information for an hour. Okay, or you won't be sending an email. It is qualitative risk because you don't have a direct influence on that, and you can't put it into your calculator or Excel sheet. Okay, and yeah. Another risk is a quantitative risk, and this is the risk you can measure. Because, for example, I'm a .NET developer with my best cloud knowledge is around Azure, so I'll be giving examples from that. But I believe that if we are talking about Google or AWS, it basically transfers. When you are creating an Azure resources, in every single resources, we can see that the SLA is 99.9%. So it translates for it being unavailable for roughly 2 hours a year. Okay, so if we have 4 resources, worst case scenario is that our application won't be available for 8 hours a week for the money we are paying. And this is the kind of information we are obligated to give to the customer and to the business. Okay, you are paying, let's say, $200 a month, and in the worst case scenario, if they decide to die one-on-one and they reach the maximum failure level, the application will be dead for 8 hours a year. However, if you decide to pay not $200 a month, but $2,000 a month, this number goes down to 15 minutes. Choose. Okay, this is a qualitative risk. You are aware of the risk, you can calculate it and present the options that have numbers both on the risk part and on the gain. Okay, if you decide to go with the lower plan with this possible 8 hours of downtime, you are saving $1,800 a month. Okay, your choice, but you can measure it. Okay, and the hybrid risk is that you both choose. You need to choose based on measurable and not measurable levels. And why I'm saying that is that there is a thing called architectural decision records, and this is the thing I have discovered after going through the architectural training, one led by one of very, very respected business architect in Poland. And he introduced me to the concept of ADRs. Basically, this is the record you create to keep your decision frozen in time. For example, as I said, we will go back to the example of 8 hours downtime for the Azure resources. Okay, you talk to the customer, you have presented them the sheet, they have seen that, okay, we would like to save this $1,800 a month, and we are ready to risk this 8 hours of downtime. It will be good. Time passes, a year, 2 years, and there is a super bad luck. All 4 of the elements go down one by one, and actually the application is down for almost 8 hours. The client is furious. It comes to you, no good whatsoever. You broke my application. My business is ruined. Yati yati yati. And thanks to keeping the architectural decision records, you are able to go back in time and tell them, see, this is the place when we decide to go with this approach. You signed for it, I signed for it, I'm clear. And the same thing goes with choosing external API, choosing a CMS. Okay, if the CMS is a totally different story. When choosing a CMS or external API, make an ADR that you're not responsible for external API downtime, and it won't be included in the application overall accessibility time. Okay, because you can't take a responsibility for that, but it needs to be noted. Okay, note on the C4 model or whatever diagram you will present to the customer the elements that you have recorded, because that can save your ass. Okay, when something goes wrong. Okay, so please keep in mind the ADRs. I don't know if you were familiar to that concept or not. They are super useful, especially when something goes wrong. And basically the concept of the ADR is that it has title, status, context, decision, consequences, and notes, but you can put whatever you wanted. It's not standardized. Okay, so in the title, you put the title. In the status, you, for example, put, we are making the decision, we are down to 3 main options. Another ADR can be decision was made, the status is done, context, we were choosing the payment provider, decision was to go with the German, French, Spanish payment provider whatsoever. The consequences are that we cannot be responsible for the downtime of the provider, and for example, you can make up to 10,000 transactions per day before your rate goes up. Okay, it's a made up consequences, but yeah, write everything down at the moment you're making the decision, because in some time you will forget it, and yeah, this decision influence the way you are working. And yeah, okay, I have 5 minutes left. Yeah, probably something like that. Okay, yeah. There are many anti-patterns when it comes to creating an architecture and team management. First one, and the most fearful one, is the buzz factor. So the number of people that need to be hit by a buzz for your project to be dead. And if this number is 1, you're in trouble. Okay, basically share the knowledge, share access, share the disaster policy, so you're not reliable on one person. First of all, that person may get sick, may get hit by a bus, or may come to you and say, I want a 200% raise. Okay, I cannot be replaced, give it. Okay, buzz factor, super important. And the thing that is very funny but very true, buzzword fog. I don't know if you are trying to be up to date with the job interview questions, but there are so many buzzwords flying around. Recently, most of them are around AI and machine learning. Basically, the fact that something is new, is buzzing everywhere on the internet, it doesn't mean it has to be introduced into your application. Make sure you need it, and don't add super new technologies to the well-established enterprises. If you have a startup, you can take a risk. If this is a well-established enterprise, don't do it. Let it settle down for the stable version and then see if it works. Okay, and the other way around, frozen came anti-pattern. So you got used to some kind of favorite Java runtime version of .NET runtime version, and you don't want to go forward because you're sure this is the best version. Withdraw anti-pattern, so everyone puts whatever they want. You as an architect lost control, and it cannot happen because this is a potent recipe for a disaster. Remember, you as an architect are responsible for the elements that get put into the brew, get put into the application. Okay, think about it, research, try it on some kind of POC, and then put it in when you are sure. Okay. Yeah, Netflix anti-pattern, it's so popular. So basically, people come to you, your developers or clients or external consultants, and they say, Netflix does it like that, I want it. And yeah, not everybody is Netflix, not everybody has the same money and the same needs. The fact that Netflix does something doesn't mean it needs to you. Remember, functionalities, drivers, all of them, and then maybe the Netflix solution works. Those are the great solutions, but for the specific problem. Okay, start with the problem, the functionalities, and then go to the solution. Yeah, this is the kind of situation we had some time ago. Basically, the client came to us and said that we need to create a recovery infrastructure for the databases, and we're discussing the project, and they were quite eager to get it done. And we asked why, because they have lost data for like 6 weeks of transaction, because they were moving infrastructure and they were hoping that nothing gets wrong. And yeah, remember, hope is not a solution. Yeah, sorry. Over engineering. So basically, this is super visible now with the AI. So putting AI everywhere, even for the simple web pages where it's needed, where it's not needed, and for some more mature products, putting in everything into the microservices. Okay, it takes money, it takes time. Make sure you need it. Okay, application has to work and bring functionality to the client. They don't care if they have microservices or not. And if they have to pay it extra, they will care, but not the way you would like them to. So yeah. Okay, and it's one of the last slides. Cool. Please keep in mind that you can't be emotionally attached to the solutions and architecture you are bringing. Okay, we are living in the shifting fashion, shifting age. Technology changes as rapidly as never. I have been getting paid for doing technology for 17 years, and it's my 9th tech stack based on .NET alone. It changes very, very fast. So please, sorry. Please be aware that the new architectural styles do emerge. Okay, there are changes in the ecosystem. There are new capabilities. The domains are changing. For example, the GDPR changed so many things. Okay, I have been working for 3 years to adjust the banking system to the GDPR alone, and it was task for 17 people. Technology changes. Okay, the external factors change. Okay, many things change. Okay, let's be open for it. Don't take it as an insult if someone comes to you and say your architecture is outdated. Okay, adapt. And yeah, if someone asks you a question about architecture, start with it depends. Okay, do the research and come back with the answer. Remember, it always depends. Yeah, it was a joke. It's a joke and not with a good one, but I like it. And we are at the very end. We are at the very end of a application. I lost it. Sorry. Yeah, I'm back. We are at the very end of the presentation, and if there are any questions, feel free.
Rodrigo, you are muted.
Oh, sorry.
Good.
Yes, we have a lot of questions, Karol. First of all, thank you very much, Karol, for your session. It's really interesting for myself, I think for the rest of our audience, and we have a full.
I'm happy to hear that.
So we can see that there are many questions in the chat, and I think Karol will go through them and answer progressively, maybe after the session. But before you wrap up, maybe, Karol, I'd like to give you the floor in case you'd like to share any final thought or comment. For my part, if we still have a bit of time, I don't know, Semi, I have a question, and my question is, it's about the C4 models. Are there any no criticism or limitation of the C4 model in real-world use?
Probably there are. I haven't reached them.
No, okay.
So, yeah. Basically, it's just a text that gets visualized. Mm-hmm. So I can't see any elements where that can be limiting. Maybe when it comes to the visualization layer and the fact that you will be having like 150 services interconnected, it may get messy, but it will get messy for you as a human with the limitations. Probably the computer probably will manage.
Okay, sure. Thank you.
If I can talk about the questions, so if anybody has a question, feel free to drop me an email. My address is on the display right now. Yes, is that? Yeah. Or maybe I can type it somewhere. I can.
Yeah.
If any of you can please leave it in the chat. Yeah, I'm more than happy to answer any emails. So,
Yes,
yeah.
of course, we will share your LinkedIn profile, okay, with
Yeah,
our audience.
right.
So we will add it to the chat and also to the broadcast that we have on LinkedIn. So if they have any questions or any additional questions or concerns, so they can reach out to
They
you.
can reach me freely. I won't answer them today. I have to go back to work. I can promise
Sure.
I will answer them by the end of the weekend. So yeah.
Good.
Okay,
No,
good.
sure. Thank you. Yes,
Thank
thank you very
again,
much,
Karol. Thank
Thank
you
you.
again for your
It
for
was a
this
pleasure.
presentation. And see you maybe in upcoming events for our Archive
I will
Fridays
be more
series.
than happy to be on that event again. I have one more presentation that will fit perfectly.
Yes, sure.
Okay.
That will be with great pleasure.
Okay.
Thank you very
See you.
much.
Have a
Thank you
great
Have a
day.
nice week.
Bye.
Bye-bye.
Thank you. Good.